That I don't know myself. I can't tell you because I don't remember.
That is the voice of H.M., Henry Mollison, the man with the most famous brain in the world.
I possibly have had an operation or something. I don't remember just where it was done.
Dr. Jacopo Annesi now holds that brain and the secrets of how it worked in the palm of his hand.
I think what made HM the most important patient in the history of neuroscience, in the history of medicine probably, is the fact that he could not create new memories.
In 1953, H.M. was a 27-year-old man suffering from epileptic seizures. In a desperate attempt to stop them, he agreed to experimental surgery that saw 2 small parts of his brain removed.
This is the lesion in the medial temporal lobe.
The seizures stopped, but there was a horrifying side effect: amnesia.
He could remember what happened before the surgery, but he could not consolidate any new memories. So he lived in this sort of short-term world, conscious world, which would last roughly about 20 seconds.
By tracking what H.M. could and could not remember, researchers figured out that different parts of the brain are used for retaining long-term memories than for recording short-term memories.
We know that your memory has something to do with the volume of the hippocampus, which was the structure that was removed in HM. But we don't really know if the way that our cells connect. And that's what makes us unique.
To understand a brain, they need to slice it.
It's thinner than a slice of prosciutto.
70 microns to be exact.
It's thinner than tissue paper.
Before slicing, the brain is saturated in sugar water, then frozen.
This particular brain is going to be about 2,500 sections, and we cut about 70 an hour. We're looking at maybe 30 hours plus of actual time sitting in front of the microtome.
A photo is taken after each cut. Every detail is controlled.
We realized that the faster you cut, the thinner it was. So you never want to change your speed as you're cutting.
The temperature is crucial.
It's very cold, that's why it rolls, because the tissue is warmer than the block. The environment where the brain is now is far too cold. It's too cold to cut. What happened is that the dry ice contracted the block and lowered the temperature all the way down to 60. Minus 60, sorry. Now it's gently rising again.
It's a sudden reminder of things that can go wrong, wrinkles in the delicate procedure that need to be ironed out before they start work on HM's brain.
For HM in particular, I wanted to make sure that everything we do is documented, because then if something goes wrong, I also have a bit of an insurance to say, well, this is the steps we took for things to go smoothly.
Each slice is mounted on a glass slide.
The box is black because this section is very opaque and whitish, so it's easier to see it against the black background.
The photos taken during slicing serve as a guide to how each delicate piece of tissue should be arranged.
Remember, it's also very important to know what's left and right, so you're sure you're not actually doing a mirror image. And the good thing about the human brain is that the 2 hemispheres are not symmetrical.
The end result is part science and part art.
If anatomy is not beautiful, it means you haven't done it right.
Different colored stains are used depending on what you want to see. A purple stain highlights the gray matter.
What stays stained is the cells, which are going to be all around the surface of the brain.
On other slices, silver nitrate is used. It takes 5 minutes to react with the tissue, turning the brain's structural fibers dark brown. Every brain has its own story.
This was an HIV-positive brain, so we'll be staining to see how HIV affects the brain.
He was a Korean War veteran. During war, he got an injury to the back of his skull. What happened was his brain bounced against the front of his skull, creating an injury in the frontal lobe, and that changed his demeanor and his personality.
Jacopo's plan is to create a digital brain library of all these cases.
It's a bit visionary as an idea. What we want to arrive to in 10 years is to have enough cases that at the microscopic level will explain what the difference is between, say, you and I. I play guitar, you're good at soccer, I'm not. despite the fact that I'm Italian. But what is in our brain that makes this difference?
When possible, Jacopo meets with the donors while they're still alive.
We need behavioral data. We need to know what this person was good at or what he couldn't do. HM couldn't make new memories. We're gonna investigate in his brain, down at the cell, down to the single cell level, why he could not make new memories.
The stained slices are scanned in microscopic detail. Each slide becomes a terabyte of data, enough to fill 200 DVDs. Those images are made available online for everyone to study. But if your computer screen isn't big enough, you can view it here on Jacopo's wall, an array of 50-inch screens where every detail is exposed.
This is a cross-section of a blood vessel that's going in this direction, while this one is a blood vessel going in that direction.
It will give researchers an astoundingly detailed view, not just of how HM's brain worked, but of yours and mine, too.
Well, the way I figure it is, what they find out about me helps them to help other people.
It will also ensure the world's most famous amnesia patient is never forgotten.